Alright, so today we are going to be starting a new way to divide polynomials. So we have started by factoring already, so we are going to review a little bit of using factoring and also dividing by a monomial. So we know that a monomial means that it has one term. So when we're dividing by something that's just one term, we can take each piece and divide by that monomial. So 6x to the fourth power divided by 3x squared. We take the 6 divided by 3 and we get 2. We take x to the fourth divided by x squared. We know we're going to subtract those powers, so we end up with a 2. 15 divided by 3, we get a 5 as the coefficient. X cubed divided by x squared, we subtract those, so we end up with a 1, which we don't need to write. 3 divided by 3 is 1, and x squared divided by x squared is 1 as well. So remember that anything over itself is 1, so just be aware there. Now we'll do the same thing on example 2, because we're dividing by a monomial. This time we have 2 variables. So we just write it out with each term divided by that monomial. So we'll take the number with the number, so 21 divided by 7 is 3. And then we take each of our variables with the corresponding variables, so a and a. So a to the fifth power divided by a, we subtract those powers. We get 5 minus 1, which is 4. Then for b, we have 3 minus 1, which is 2. 14 divided by 7 is 2 for my coefficient. A cubed divided by a, we have 3 minus 2 for the power, 3 minus 1 for the power, which is 2. And then for b, we have 2 minus 1, which is 1. 63 divided by 7 is 9 for the coefficient. A squared divided by a, we have a to the power of 2 minus 1, which is 1. And b divided by b is 1. So we don't have to write times 1 on the end, because we know that anything times 1 is itself, so we would just leave the b out of it. So that's dividing by one term. And then we saw on Friday how to use factoring to divide by a binomial. So in order to divide by a binomial that can factor out, we would, let me just go ahead and write it as factors on the top, divided by w minus 5. So w squared minus 7w plus 10. I need two numbers that will multiply to 10 but add to negative 7. Those two numbers are negative 5 and negative 2. We got negative times a negative will give me that positive, and then we have 5 times 2 is 10, negative 5 minus 2, negative 7. Anything that is on top and on bottom will cancel. So w minus 2 is my answer. We can do the same thing even when we have an a value other than 1. So on number 4, we have 4h squared minus 7h minus 2. So we're going to use the slide and divide method to factor this. So I'm going to take 4, multiply by negative 2, change this to h squared minus 7h minus 8. So then I need two numbers that will multiply to a negative 8 but add to negative 7. So that's h minus 8 and h plus 1. And we will divide both of them by 4 since we multiplied by 4. So 8 divided by 4 is 2, so this changes to h minus 2. And then this becomes a fraction, so the 4 will go before the h. 4h plus 1. And then we're dividing by h minus 2. H minus 2, is on top and on bottom. So then my answer is whatever is left over, which is 4h plus 1. So now what if we cannot factor? Well, there's two different ways that we can divide. We've got long division and synthetic division. We're going to start with long division, and then we will go over synthetic division a little later this week. So with long division, we do need a refresher on how to use long division with numbers, because it's been a very long time since you've had to do that. So we're going to do an example with long division that has to deal with just numbers. So it has nothing to do with number 5. It's just a refresher on how to do long division. So we would check how many times can I take 4 and put that into 6, that first number. And we know that it can go, not twice, sorry, once, which we would multiply 4 and 1 to get 4. Subtract from just that first number. So 6 minus 4, which is 2. 4 does not go into 2, so we drop that 5. And 4 goes into 25 6 times. 4 times 6, bring that down here. Subtract, we get 1. And we are going to stop here. So I know that you can add the decimal and keep going, but 4 does not go into 1, so we'll stop. And we would say that 65 divided by 4 equals 16 remainder 1. So when we do long division of polynomials, we're going to do a very similar process. We're going to take x plus 8, the part that we were dividing by, put it on the outside. And x squared plus 3x minus 43 will go underneath. So when we were looking at our example, we started with 4, said how many times can that go into 6? We'll do the same thing, but we're going to focus on the x when we're looking at how many times can it go into something. So how many times can x go into x squared? We know that we would have to multiply by an x to get there. So x times x gives me x squared. And then x times 8. So make sure that we are multiplying by both parts, which would be 8x. Now this is where it gets a little tricky because we are subtracting. So since we are subtracting, we're subtracting the whole thing. So they both become subtraction. X squared minus x squared, perfect. 3x minus 8x is negative 5x. And then just like we brought down the 5 over here with the 65, we're going to bring down that minus 43. Then we'll do the same thing. How many times does x go into negative 5x? So negative 5x divided by x, I would need to multiply by a negative 5. Now we're going to take that negative 5 and multiply by 8. So negative 5 times, by both terms. So negative 5 times x first, which is negative 5x, and negative 5 times 8, which would be a negative 40. But again, we are subtracting the whole thing, so both of the signs will change. Negative 5x plus 5x cancels, that's what we want. Negative 40 plus 40 is negative 3, but I have nothing left to drop down, so that is my remainder. So we could say that x squared plus 3x minus 43 divided by x plus 8 equals x minus 5 with a remainder of negative 3. Don't worry, we are going to do some more examples just to make sure that we see it enough times before we throw you in there. So again, we're going to do synthetic division on Wednesday. So we are starting with long division. So we're going to continue using long division with the next page of notes. So here it just says that it is very similar to long division with numbers, which we saw on that example with 65 divided by 4. So we need to make sure that when we're dividing polynomials with either method, that they are in order and each term must be included. So this is really important. And this is super important. So we need to make sure they are in order with our highest degrees all the way in the front, and then each term being included, we need to make sure that if something is missing, we put that 0 there. So I'll explain how to do that on example 2. So on example 1, we're going to take x minus 3 on the outside, and 3x squared plus 5x minus 28 on the inside. Focusing on x, we're going to take x into 3x squared. So if you need scratch work, you could take 3x squared and divide it by x, which would give me 3 divided by 1, which is 3, and x squared divided by x, which is x. So 3x is what goes on top. And then again, if you need scratch work, you're taking 3x now and multiplying that by x minus 3, so you're distributing it. So we know that we're going to end up with 3x squared because we divided that straight out. But now 3x times negative 3, which would give me negative 9x. Now this is where a lot of mistakes will most likely happen. Make sure you change both of their signs each time. So now we have 3x squared minus 3x squared. They cancel. Perfect. 5x plus 9x, which is 14x. And then minus 28. Make sure we bring down that last term. Now we'll do the same thing, but with 14x. So 14x divided by x. 14 divided by 1 is 14. X divided by x is 1. So we have plus, since it's positive, 14. And then we'll take 14 and multiply it by x minus 3. So 14 times x is 14x. 14 times negative 3 is negative 42. Make sure we change both of their signs, so minus then plus. 14x minus 14x, they will cancel. Negative 28 plus 42 is a positive 14. And since we have nothing left to drop here, then this becomes my remainder. So my answer is 3x plus 14 with a remainder of 14. Now we'll do the same thing on example 2, but like I said, we need to make sure that they are in order and that each term is included. So on example 2, we go 4, 3, 1. So we're missing x squared. So when we write out underneath the underneath the division symbol, we'll have 4x to the power 4 plus x cubed plus 0x squared plus 16x plus 5. And then we'll make sure that this is in order. So we'll put 4x plus 1. So be sure that when you are rewriting things, you keep their signs as they are. So the 4x is positive and the 1 is positive. So we have 4x plus 1. So just like when we only have an x, if we have 4x, we're focusing on 4x. So 4x into 4x to the 4th power would be, x to the 3rd. And again, if you need that scratch work, then you would take 4x to the 4th and divide it by 4x. The 4's will cancel. We get x to the 3rd. Then we'll take that x to the 3rd and multiply by 4x plus 1. So we get 4x to the 4th, and then x to the 3rd times 1 is x to the 3rd. We are subtracting, so we got to make sure that we change both of those signs. These two cancel. And then x to the 3rd minus x to the 3rd is 0 x to the 3rd. Bring that down, 0 x squared. Bring that down, plus 16x. So now we're trying to take 4x and put it into 16x since these two are gone. So 16x divided by 4x. 16 divided by 4 is 4. X divided by x is 1. So we have just 4 here, which gives me 16x. And then 4 times 1 is 4. But remember, we are subtracting every single time, so those two will change signs. 16x minus 16x cancels, and then here we have plus 5. So 5 minus 4 is 1. So there's a giant gap between the two on the top there. So we have x cubed plus, since it's positive, 4 with a remainder of 1. So that gap comes from there not being an x squared term or an x term. So just be aware of that. And then we're going to do 2 more. We're going to do practice 1 and practice 2 together. So on practice 1, we just got to make sure that all of my powers are here. It starts with 2, then it goes to 1, and then to a constant. So this is good. And then we'll make sure that this is in order, so that x is first. This is good. We'll write 3x plus 1 on the outside, 15x squared plus 8x minus 12 on the inside. We'll use our scratch work over here. We're going to take 15x squared, focus on the first term, 3x. 15 divided by 3 is 5, and x squared divided by x is x. So 5x goes on the top here. We'll take that 5x and multiply by 3x plus 1. Gives me 15x squared. And then 5x times 1 gives me 5x. Remember that we are subtracting, so both of their signs will change. 15x squared minus 15x squared cancels. 8x minus 5x is 3x. Bring down that minus 12. So now we have 3x divided by 3x, which we know is 1. So plus 1 on the top. Then 1 times 3x plus 1, sorry, I almost said minus. Gives me 3x, and 1 times 1 is 1. Change both of those signs. 3x minus 3x cancels. Negative 12 minus 1 is negative 13. There's nothing left for me to drop, so this is my remainder. 5x plus 1 with a remainder of negative 13. And then on practice 2, we're going to check first that we're in order and that we have all of our parts in there. So to the power of 4, the next should be to the power of 3, the next should be power of 2. So we're missing the x squared term. So just make a note there, power of 1, and then a constant. So once we find out that we're missing x squared, we're good. And then x is first here, so we're good. So since we are missing something, we're going to put a 0 there. So 3x to the 4th minus x cubed plus 0x squared plus 5x minus 1 divided by x plus 2. So for our scratch work, we would take 3x to the 4th and divide it by the first term of x, which gives me 3 still, and then x to the 4th divided by x is x to the 3rd power. So then 3x cubed goes on top. We'll take that same thing and multiply it by both terms, so x plus 2. Since we divided it straight out, I know it's going to give me 3x to the 4th in the front, but then I still need to multiply by that second term. So 3x to the 3rd power times 2 gives me 6x cubed. Change both of those signs. Minus, minus. Cancels. Negative x cubed minus 6x cubed is a negative 7x cubed. Bring that down. Since we have something in the front, we'll just work with that. Negative 7x cubed divided by x gives me negative 7. X cubed divided by x is x squared. So minus 7x squared goes on top. I know it's going to give you minus 7x cubed, but I still got to do the second term. So negative 7x squared times 2 is negative 14x squared. Change both of those signs. Plus, plus. Cancel. 0x squared plus 14x squared is 14x squared. Drop that 5x. So we got 14x squared divided by x. Which gives me 14x squared divided by x is x. So positive 14x goes on top. 14x squared goes there. And then 14x times 2 is a positive 28x. Subtract, so change both of their signs. 14x squared minus 14x squared will cancel. 5x minus 28x is negative 23x. And then I gotta drop that 1 all the way down here. So negative 23x divided by x. Negative 23, x divided by x is 1, so it's just negative 23, which would give me negative 23x. And then negative 23 times 2 is negative 46. Running out of space there. Change both of those signs, so plus, plus. These cancel. Negative 1 plus 46 is 45. There's nothing left for me to drop, so this is my remainder. So my answer is 3x cubed minus 7x squared plus 14x minus 23 with a remainder of 45. So then for your homework, you have 6 problems where you are dividing using long division. So make sure that you are using that method because we will be checking for that. So just get that practice in using long division. All of this will be posted and ready for you to copy if you need it.